Hey everyone, welcome to another CGMK King tutorial. This one is going to be based on a little tool that I created, and it's actually very useful and very easy to set up. I call it the wrapper. So let's get started. So here we are in Houdini. I just created the project and created a Houdini scene where we only have a bunch of models. So this is a card that I imported from an OBJ of a card that I imported from a library. Then we also have the traditional rubber toy, all-purpose test animal. And then we also have Greg here, so we can test the tool with different elements. And I also have a more challenging element, which is the squab. Okay, so the tool is going to be, let's start with the car. In some situations, you might want to make sure that you have kind of a simplified version of your object that's completely watertight. If we use the typical approach where you would use VDB from polygons, we would kind of, let's go with 0.05 and convert this to VDB, and then we convert VDB back to polygons. So this might work, but in some situations, it might not do the trick, because sometimes you have open geometries, and this is not the case. But imagine that instead of having this, you had something like this. Let's imagine that for optimization purposes, the model that you're receiving doesn't have isn't made up of closed geometry. This will immediately become problematic when you try to use this approach. The VDB from polygons approach kind of breaks everything apart. Okay, and for this type of situation, you can even try. Right now, we also have the voxelized mesh, levels voxel mesh, and this is also a valid option. And as you can see, the voxel mesh does some other operations to make sure that, or to try to prevent that issue that we had before. But still, the result doesn't really match the volume all that much. Of course, we can fine tune it, give it a bit more resolution, dilate and erode. But I believe there's a simpler way, and that's what I'm gonna try to show you. And I think it's one of the most useful tools that I've created for myself, and I've used it so many times in so many different situations that I thought that the application of this is really worth making a tutorial and sharing it with everyone. So my approach was, I thought about creating a system that would allow me to kind of have start with a big mesh that envelops the whole object, and kind of slowly or gradually have that big mesh enveloping the object shrink into the shape of the object, and eventually wrap it up very, very closely to its original shape. Let's pull this aside as options, and I'm going to start working with full solid. It won't make much of a difference at the end, you'll see, but let's start with the whole car. So the process is actually quite simple. We actually have an object or a node that generates that enveloping box. Okay, we have a bound. Great. So this is going to be our starting point. We can always connect whatever we connect here. We can make sure that we'll be sure that this bound will always envelop the whole object. Of course, you might want to kind of increase the padding, but you probably won't need it. The next step is, if we want to be able to adapt this geometry to what we have inside, then we can't really rely on just these points to do that adaptation. So the next step is going to be to use a remesh. And remesh isn't the fastest node of all times, but we'll start with the target size that we're going to insert ourselves. Though there are many different ways that we can go by and kind of procedurally calculate based on the size of what's coming in. But for now, let's just focus on something like this. 0.2 is fine. So let's remesh our box. So now we have a lot more geometry to work with. So the next step is going to be for us to kind of apply um, array node where, let's put this here. We apply array node, and then we just project the original geometry using array node with minimum distance. And now we're kind of getting closer already. Even if we were just to consider this shape, let me turn this off. We're already getting close to the original shape, and we haven't done pretty much anything at all. Just bound, a remesh, and array. Pretty straightforward. Now, once we have this, we can actually go through the process of converting this to VDB. Again, VDB from polygons. This is where we're gonna set the final resolution that we want. So let's go with 0.05, VDB from polygons, and then we'll go with reverting the process of converting VDB back to polygons. Okay, so we still have a few issues, but what if we just repeat this process again? Another array and another VDB from polygons. So if we grab this and we copy it, wow, we're getting closer already. From here, we passed to this. So by now you already figured it out that the idea is going to be for us to create a for each loop, and we will be determining the amount of iterations that we want to do. The more iterations we do, the closer we'll be getting to the final shape. So let's delete these and actually create a for each loop. Let's for each number. And let's make sure that this is coming in and this is connecting here. And then we convert to VDB. Now here we might want to make a few changes, of course. So we don't want to fetch the input every time. Here we want to fetch the feedback. And here we want to make sure we don't merge each iteration with feedback each iteration. And this will be the number of iterations that we do. Let's have a look at 4 iterations. How close do we get? Pretty cool, right? Very, very fast, very easy to set up, and extremely powerful, and you won't believe how useful this is. How many applications I found for this. Okay, so now we can set up, let's say, height as a base number. And we can, of course, continue to tweak this, add just some extra features that will allow us to make a pretty cool HDA to use very easily, very powerful as well. But first, let's try to kind of work on the finishing of this. Because once you, the final output is the result of a array, a VDB from polygons, and a convert VDB. So but as you can see, we can probably take this a bit further. Let's say if we start going for higher level of detail, 0.025, something like that. Okay, really cool. We have a lot more detail going on here, and let's see if we can. How much would we gain by using another array at the end, right before exporting the model out? So let's get this again. Minimum distance. Let's hide the guide geometry. And as you can see, from this point to this point, we do get some detail back, but we might not want to have all this distortion happening everywhere. So again, it's up to you if you want to apply an extra pass of ray. And if you do, I would suggest that you control it with the scale, because we don't need to apply the transformation to the points at full. We can just go 0.5. So if we apply a scale of 0.5, we do get a more approximate shape, more accurate shape, without having to without having all that distortion. Another thing we can add, and whenever you apply array, even especially if it's at 100%, you might want to update your normals, and this will show you exactly what you have. Already compared to the previous options that we had, we will notice that we would have a huge gain. Let's turn off the blast and actually connect this here as well to see the result with the blast. And as you can see, we do get some holes here. There is something that's missing, and it's very thin here, but it's still pretty robust. This would still work for most applications where you might want to have something like this. This would still be a good option, and of course, much better than this one. And I think still kind of winning some points too over this one. Now, other features that you might want to include, and for the sake of this, I'm just gonna for now turn off the blast. Um, Other features that you might want to add to your HDA is the ability, and this is something that happens also often, is you might want to apply a poly reduce. So you might consider that as well, poly reduce, where we would have that option with the switch. Expose this parameter. And the other thing would be the attribute transfer, which is something that you might want to do. Transfer the attributes from the original mesh to the mesh that you're going to be outputting. Again, with the switch as an option. And this would be the end of the tool, the output. Okay, so let's turn this into cool HDA. I'm gonna just add a null here. I'm gonna press F9. I have a shortcut for the update, so I'm just gonna press F9 to toggle that. And let's call this in. Okay, let's convert this to a nice HDA. I'm gonna select everything, press Shift C to convert this to collapse this to a subnetwork. I'm gonna call this Geo Wrap. Right mouse button, create digital asset. I'm gonna save it here. It's fine. And David Geo, I'm gonna version it just because force of habit. Geo Wrap sounds good. Accept. And now for the parameters, I'm actually gonna just bring most of it from here. So this remesh, we're right now using setting a value, but what we're going to do, and the most important value, is definitely going to be the target resolution for the final mesh, and this is going to be our reference. So what I'm going to do is actually copy this here, and also the number of iterations that we have. The other thing will be to, regarding the poly reduce, I'm gonna make sure that we have a switch here, or a toggle. I put here a toggle called toggle reduce, and I'll also have the parameter available, this percent to keep. This percent to keep, I only want it visible if this is on. So I'm gonna use this expression. I'll hide it whenever this is equal to 0. And for this one, is pretty much the same thing. The attribute transfer will have a toggle here. Trans toggle. And I'll just write attribute transfer. And we'll expose some of these parameters. Definitely these options. We can actually get it from the nodes that are inside. So if you go here to the attribute transfer, attributes, and we can just copy this here. And for the conditions, I'm just going to expose the distance threshold right here at the beginning, and it's going to be fine. Here for the attributes transfer, I'm going to make this a simple section. And again, I'm only going to expose these parameters if the toggle, so let's hide this, if the toggle attribute is equal to 0. Apply, accept. I'm going to pull my second windows. So now we have this Geo Wrap, we have these parameters available, and I'm gonna check. We're missing the other toggle. It's probably something I forgot. Type properties. Okay, so let's see what's happening here. So we have the percent to keep percentage, and this toggle is wrong. So this expression we wanted to apply to the percentage actually. So let's grab this, put it here, and we should be good to go. Let's apply it and see how it looks. So poly reduce exposes that one, and attribute transfer exposes distance threshold and all the attributes that we might want to consider as well. And let's hit accept. I think that's all, just making sure that we have this as the output. Let's go up. Save node type. I'll match current definition. And we got our HDA. Let's go and hit F9 to let it run through again. Oh, there's one thing missing, and that's, let's open allow editing of contents. Hit F to kind of frame it. And the missing element is just because we need to apply an expression here on the remesh. So the target size is going to be dependable on the voxel size. So let's copy this parameter, and I'm going to hit F9 again so it doesn't try to update manual. Base relative references, and let's multiply this by 10. This is a good number. It should work for most situations. Still pretty fast. I find that for most objects that I try to apply this, 8 iterations is more than enough. So I'll keep this as a default value, and also the voxel size 0.025. Depends on the scale that you work. Of course, if you're working on environments and kind of wrapping big elements, then this value might be dangerous, but just keep that in mind. I'll save node type and match current definition. And let's give it a try on the other objects. Okay, so let's go to we have our wrapped car. Let's go to our rubber toy. Geo Wrap. There you have it. Some elements aren't quite there yet. You can of course fine tune this, but it's still pretty powerful and pretty fast to calculate. If you give it more detail, then it takes longer, but you might be able to get rid of some of these elements. Let's apply poly reduce. Right now we have just to make sure everything's working, we have 1000 points, 100,000 points. Let's switch this to 10. And it's not doing anything. Let's allow editing of contents. Of course, I forgot to connect one thing to the other. So we have it here. We're on the rubber toy, and I forgot to connect these with our network actually. So the poly reduce will copy, and we say it's base relative reference on this switch. I'm going to change the name of it, switch reduce, and this is going to be switch transfer. Okay, so now the reduce is working. We should have something around 10,000. We have 5,000. It's actually much more optimized. And also the attribute transfer. If we actually had something on the object, we could, we'll see the switch happening here, or we should copy. And here, base relative references as well. So now we have that transfer happening, and we can choose what we want to transfer. So I'm not going to transfer anything. Right now it's trying to grab point element, probably normals or something like that. Okay, so it should be working. Now I'm just gonna give you a few more tips on how to get rid of some of these elements. One thing we can do is here on the VDB from polygons, or better on the convert VDB, when we're converting, we can actually play with the ISO value and use a negative value, something like this. Okay, and as you can see, we do get rid of those kind of membranes that we have, but we do kind of start eating away some of the elements as well. So to make sure to compensate for this, we would then apply a peak after everything. So let's go here, and I'm going to increase the voxel size to 0.02. And again, our reference is going to be the voxel size. So let's copy parameter. And here on the convert VDB, on the eval value, I'm going to say base relative reference. And I'll divide this by, let's say, 8. So we want a very small number. And then on the peak, we'll base relative references and divide it by 4. And it's still generating all this thickness here. We convert to VDB and then convert back, and it's not getting thin enough because I am using a positive value. So forget all that and just remember that this needs to be a negative value. Yeah, so now this should definitely work better. Let's have a look at it again. We were kind of pushing out twice with the peak and with the ISO value here, so it is getting thinner. And if we go all the way to 32, I'm hoping this will be enough. Okay, and it gets closer and closer. So depending on your patience levels, if you're willing to wait for it a bit more, then you can completely get rid of these. So let's have a look at the result that we get from the crack. This should be a challenge. Let's have a look what we get here. So F9. It's a pretty complex element. So let's see how good this does. Geo Wrapper. Okay, so this is definitely more of a challenge. It does a great job here on the hammer, but we have so much hollow space in between the arms and the torso that this would definitely require more, probably more detail as well, and probably more iterations to get closer. Let's see, 32. Yeah, it didn't win. We did get the start to get this arm properly. So we would need to continue to push this for a lot more iterations. So I invite you to kind of test it out and see how far it goes. Let's have a look at the other one. Also a bit of a challenge. I'm going to interrupt this. Let's go to the squab. So this is a complicated object, and we have very long elements and small distances in between them. So this is the perfect situation to have those types of membranes that we were having before. Let's apply the Geo Wrap. and not too bad. We do have a bit here. Maybe add a bit more detail. 0.01. Okay, so a lot of more detail, but we're gaining some membranes, so we would need to kind of take the iterations a bit further. So what I'm going to do is press F9, go to manual update 0.05015, and then let's try 16 iterations. Again, it might take a while, but let's see how far this goes. It gets very close to so close to the shape that it kind of starts to be in look faceted as well. Yeah, with a few more iterations, we'll definitely get rid of this. So let's go to 32, and we'll wrap this up. We'll wrap this up. So yeah, while this calculates, I hope you enjoyed this one. This is, again, I just felt that it made sense to share this one because it's really very useful. So we didn't got rid of these weird elements, but we could, in this situation, probably get away with delete small parts and just extract the largest piece. This definitely help, I guess. Still a few elements here and there. Yeah, you might need to fine tune those parameters between the peak and the ISO offset. But overall, it does a pretty cool job. We are kind of working with a very detailed model, so yeah, it's bound to have its limitations, but it's very powerful. Okay, hope you enjoyed this one, and I'll see you on the next.